Hi, this is Kyle Haynes speaking technically with Source Allies. Today, we're going to learn about virtual threads, which are probably one of the most exciting changes or the additions to the JVM and the Java ecosystem in a long time. Virtual threads are one component of a larger initiative called Project Loom. And Project Loom's main goal is to make it very easy for application developers to write highly concurrent applications. So today, we're going to talk about what kind of applications will benefit the most from virtual threads. We're going to do a little bit of a deep dive into how concurrency works today on the JVM, as well as how virtual threads fit into that. And then we're going to talk a little bit about how we can utilize that with Spring Boot, and we'll do a quick demo. So let's get going. Let's see. So what type of applications will benefit from virtual threads? When you're talking about Java applications, most of the time, you can think of two types. You're either going to be bound by CPU, where you're spending most of the time on one machine processing, doing things like image resizing or video processing, complex mathematical operations, things like cryptography. Those are all where you're on one machine. Versus I/O-bound tasks, where you're doing file operations, maybe you're calling an API, interacting with a database, things where you're taking requests from your machine and calling out to other machines to get extra data. So I/O-bound tasks are always going to see the biggest benefit from virtual threads. So why is that? Let's dive in a little bit. In this example, we're going to pretend this is our Java application. Now, to best understand platform threads, we need to understand how the JVM interacts with operating system threads. So on your operating system, based on how big of a CPU you have, you'll have a big number of operating system threads, but it's a finite number. You can't have millions and millions of these. So if you have a small CPU, you have a small number of operating system threads. If you have a bigger CPU, you have a lot. So again, these are finite, and the JVM will map your application's platform threads onto an operating system thread. Remember this because it's gonna be important later. But anyway, what's going to happen? Most REST APIs or Java applications are set up to where you have a consumer calling into your application, and when a request comes into your application via, like a REST API or whatever, when a request comes in, it's going to get handled the entire time from front to back, the entire length of time it's in your application on a single platform thread. That platform thread, for example, if you're in an I/O-bound application that needs to call a database or make a REST API call, it's going to make the calls out, and what will happen is, say your API takes 2 seconds to call some other REST API. That 2 seconds while your thread is calling that other API, it's going to be in a state that we call blocked. So we'll mark that with an X. In a blocked state, that platform thread is sitting there just twiddling its thumbs, waiting for something to happen from this other API. So it's waiting for data to come back. You can see what could happen if you had multiple consumers and multiple requests coming in. As more and more requests come in, more and more of your platform threads are going to be blocked from accessing your other I/O resources, your databases, etc. So the next question is, how do you scale? When this kind of situation happens, your server is going to slow down, you might drop requests, there might be errors, your consumers are not going to be happy with what they're getting. So how do you scale? The first option is you go vertical scaling. You get more consumers and you just say, all right, since I need more threads, I'm just going to get a bigger CPU. So I go from maybe a 1-core CPU to a 2-core CPU. That gives me more operating system threads. That lets me get a higher concurrency and higher throughput on my application. That's great and that works, but it's also expensive. A lot of times you're going to be paying double each time you step up in size of application. So that's one option. The next option is horizontal scaling. We see this a lot. A lot of times we do it for redundancy, but we also need to do it so we can handle the scale we want to look for. An example like this, you would have maybe instead of one application, you'd have 3 or 4 applications, and your load balancer is going to kind of round robin send those requests to each application on the back end. Again, this is more expensive. You have more applications, and you're still blocked from these platform threads calling I/O. The next option, this is pretty, newer in the Java world, isn't really that new, but reactive programming is maybe the last 10 or 15 years has been kind of hot topic on how you can scale better. In this kind of an example, reactive programming has requests coming into a single platform thread, and that platform thread kind of offloads events to an event loop. And that event loop will register callbacks and all that good stuff for your application to be effective and keep processing correctly. What'll happen is these platform threads will call off to the I/O, and then behind the scenes, as events come back, they are registered and goes back on the main platform thread and back to consumers. This style of programming scales really well, but unfortunately, you got to completely change the paradigm you're used to. So most of the time, you might be doing imperative style programming, and that gets you up to this kind of a stage. But in order to make the flip to a reactive model, oftentimes it could be a complete rewrite of your application or a substantial rewrite in order to fit this type of application. So where virtual threads come into play, they try to keep you so where you're doing the same virtual threads, try to keep you so you're on the same type of programming you've been doing in the past without reactive. And what will happen is requests will be coming into your application, and virtual threads will get mounted onto your platform thread. And the cool thing is, as soon as the JVM realizes that I'm about to make my 2-second web service call, as soon as my thread blocks, instead of blocking the platform thread, I'm going to block the virtual thread. And these virtual threads actually get moved down to the Java scheduler, clearing up the platform thread completely. What this lets us do is, while this 2-second call is happening, instead of this guy being blocked, another request can come in. So I could spin up another virtual thread on that same platform thread, and I can make another request maybe to a database. And that guy, as soon as it realizes it's blocking, waiting for data to come back from the database, it gets put away. And then as soon as my 2-second API call comes back, that virtual thread can get remounted back onto a platform thread and get sent back to my consumers. And then it's actually just deleted. These things are designed to be short-lived, and they're incredibly lightweight, incredibly fast to create. So that's virtual threads in a nutshell, and why they get platform threads kind of allow us to keep handling the requests. And we're going to dig in to a demo really quick to show you the benefits here. So I have a Spring Boot application. It's incredibly simple. We have an endpoint called test that is going to, all it is going to do is sleep for a second. What this sleep does is it blocks the thread. So what we'll see is we'll send a request off, it'll block for a second, and then return data back. What I have set up here is a bit of a load test. So we're going to run a load test that spins up to 1,000 users. 1,000 users will simulate hitting this endpoint, and we run it for about 35 or 45 seconds, and then we'll see what kind of performance we get from the application. So we're going to run this, and we will be back in a little bit when that's done. We'll kind of fast forward. All right, we are back. So we completed, it took us 45 seconds. We spun up 1,000 users, and in that time we completed 8,382 requests. So that seems good. When we look at the duration, this is one of the fun parts of this example, I think. The request duration averaged 3.47 seconds, and the P95 was over 4 seconds. And you're looking at that and you're kind of confused, like, how did I average 3.4 seconds when my thing said I was only supposed to sleep for a second? I think what's happening here is Spring's got an internal thread pool size. I believe it's 200 by default. And what'll happen is, since we're running on a container like Tomcat or something like that, it'll kind of build up a backlog of requests that need to be coming in. So while I'm sitting here trying to process, or I'm waiting for a second, I'm kind of also building up a backlog. And that backlog causes requests from consumers. Even though it's not in my app for a second, the consumer's perspective, it looks like it's taken up to 4 seconds. So that's platform threads. That's existing Java. Now, the great part about this is, as all good Spring Boot apps have, there's a virtual property. So spring.threads.virtual.enabled. If we set that property to true and restart the app, I do want to talk a little bit about, we'll start that back up. This is running Spring Boot 3.2.0. This is not released yet. It is coming out in November. So you can get kind of pre-release, you can go play with this, but if you're relying on Spring Boot for production purposes, this isn't quite ready yet, but it's coming. So we're going to rerun the same script, and we will be back again when this thing completes. All right, we are done. We're back. That one only took 42 seconds, and the cool part here is we did 17,980 requests. So last time on normal platform threads, old Java, we did 8,000 some requests. Now we're almost 18,000 requests. We're almost 10,000 requests more for the exact same test. And if we look at the HTTP request duration, we're at 1 second. The P95, 1 second. So that's the power of virtual threads and how easy it is, especially if you're in something like Spring Boot where you can just flip an application property. This is super, super cool. Really goes to highlight if you're running something in the cloud or something where you're paying for the CPU cycles and you're paying for a bigger machine. Maybe you've got a chance with this upgrade to down level, like go from 2 CPUs to 1 CPU. You might be able to come down and save your company money. And you get to upgrade to the latest Java version. So it's kind of a win-win for everybody. So I have been Kyle Haynes, speaking technically with Source Allies. If there's something you'd like to see us cover, please comment it down below. Otherwise, if you'd like to know more about Source Allies, check out the link in our bio, and we'll see you next time. Thanks.